Okay, this is the second video on factoring, and for this, we're going to look at some special types of factoring that you should recognize. One is not all that important, the other one is. So first off, suppose we have something like this, x squared minus 16. My leading coefficient is 1, like the polynomials we did in the last video, but in this case I don't have a trinomial, I have a binomial. And well, this might seem different. You can actually set it up exactly the same way we did the last one. Like I said, it's not a trinomial, but write it as a trinomial. X squared plus 0x minus 16. Now it's a trinomial, the leading coefficient of 1, we can do what we did last time. The only thing that gives me x squared is x and x. Now I need two numbers that multiply to negative 16 that add to 0. The only way they can add to 0 is if they're the same number opposite in sign. So it's clearly got to be plus 4 minus 4. 4 times negative 4 is negative 16. 4 minus 4 is 0. This is actually a special case. It gets a special name. It's called a difference of squares. Essentially, it's pretty obvious. X squared is a square, it's x squared. 16 is a square, it's 4 squared. And it's a difference because you're subtracting, hence the name. But the point is, once you understand that, there's a general formula that you can use to solve all differences of squares. A squared minus b squared will factor to a plus b, a minus b, which is exactly what we got here. X squared, the square root of x is x. 16 is 4 squared, and we got x squared minus 4 squared is x plus 4, x minus 4, right here. Once you understand that, you can solve these pretty easily. So, to run through a few examples, suppose I have x squared minus 25, and maybe we'll go with 25x squared minus 16. And then we'll do one more, but I might need more room for that. So if I look at this, it's a binomial, it's a difference. X squared is a square, it's x squared. 25 is a square, it's 5 squared, which means it's a difference of two squares. So it should factor to the square root of that, plus or minus the square root of that. You can write it this way, x plus or minus 5, or you can expand it like we did before, x plus 5, x minus 5. That's normally how I will write it. I'm fine with you writing it either way. This one looks a little bit different, but it's still two terms. It's still a difference, and all I do is check everything. 25 is 5 squared, x squared is x squared, 16 is 4 squared, which means it's still a difference of a bunch of squares, so I can factor it the same. The square root of the first term is 5x, plus or minus the square root of the second term is 4. So I get 5x plus 4, 5x minus 4. It doesn't matter how convoluted these look, as long as you can show the first term is a bunch of squares multiplied together, the second term is a bunch of squares multiplied together, and it's a difference, then it's a difference of squares. So one more just for fun. Suppose I have 2x to the fourth minus 162. I want to factor that. Well, first off, 2 is not a square. 162 is not a square. The x to the fourth, we might be able to manipulate a little bit, but that's clearly not a difference of squares. But you guys remember factoring from the last video? When you're factoring, the first thing you generally look for is a common factor, a GCF. And in this case, there's a 2, there's 162, that's a common 2. I can factor that out, and then I'm left with x to the fourth minus 81. Now I look in here. 81 is clearly a square, it's 9 squared. X to the fourth is actually x squared squared. So that's definitely a difference of squares. And I can factor it. The 2 will just carry along on the outside because it's a GCF. To the square root of x to the 4th, which is x squared, plus or minus the square root of 81, which is 9. Which again, I can expand to 2, x squared plus 9, x squared minus 9. But keep in mind, once you do that, you have to look at each of these factors individually. X squared plus 9, can that be factored again? In this case, no. X squared is a square and 9 is a square, but that's a sum. And there's no rule for a sum of squares, so that can't be factored. But here, x squared is a square, 9 is a square, and it's a difference. This term can be factored again, which means I rewrite everything that can't be factored, the 2 times x squared plus 9. This term factors again to x plus 3, x minus 3. Now, nothing can be done with the 2. We already said this can't be factored. X plus 3 can't be reduced anymore. X minus 3 can't be reduced anymore. Now, everything is in lowest terms. Now it's completely factored. So just be aware when you're doing these, do not stop after one step. Sometimes when you factor, all you'll have is a GCF. But you still have to check to see if you can factor again. Oh, here we could. We got a difference of squares. But don't stop there. Sometimes you will, but there's a possibility that your factors can be factored again. Make sure that you're checking at each step along the way to make sure you're factoring things completely. The last thing we're going to look at, suppose I have something like a cubed, I'll go with x again, I like x is better. X cubed minus 8. That is clearly not a difference of squares because that's a cube and 8 is not any number squared that we know, a nice, simple, perfect one. So that's not a difference of squares. There's no GCF, it's not a trinomial. What exactly do we do with it? And there actually is a class of factoring we can do for what's called a difference of cubes. And there's also a sum of cubes. For the purposes of this class, you need to know what these are and recognize them. All things being equal, if you don't necessarily memorize the formulas, it's not going to hurt you all that much, but you should recognize them so that when you see them, you can say, oh, that's a sum of cubes, that's a difference of cubes. So you know how to factor it and don't just think, I have no idea what to do with that one, I can't do anything. And the actual formula says, for a difference of cubes, if you have a cubed minus b cubed, it factors to a minus b times a squared minus 2ab plus b squared. I'm sorry, that's not a 2 right there. Plus b squared. For a sum of cubes, a cubed plus b cubed, it factors to a plus b, and when I wrote that, that should be a plus right there. The way this works, and we'll compare them here, if it's a difference of cubes, the first factor is a difference, the other two have to be sums. Here, this is a sum of cubes, the first term is a sum, which makes the first one here a difference. The second term is always a sum. So the only difference in these formulas is what comes first and second. Everything else is the same. And you just have to remember, if it's a difference of cubes, the first factor is a difference, the second one is a sum. If it's a sum of cubes, the first term is a sum, so the second term is a difference. The third term will always be a sum. So for this right here, x cubed minus 8, that's clearly x cubed minus 2 cubed. So when I factor it, I get x, it's a difference, so minus 2 times, now disregard this entirely, just use this. It's a minus b, then you square the first term, so x squared, plus, then you multiply the a and the b together, 2x, plus, now you square the last term, 4. And now that's factored for your difference of cubes. If you want to check it to make sure it's right, we'll just quickly FOIL this. FOIL, x times x squared is x cubed, x times 2x is 2x squared, x times 4 is 4x, negative 2 times x squared is negative 2x squared, negative 2 times 2x is negative 4x, negative 2 times positive 4 is negative 8. If I combine like terms, there's an x cubed, 2x squared minus 2x squared cancels, 4x minus 4x cancels, I'm left with minus 8. And there's the x cubed minus 8 that I want. Again, these are not incredibly important, but they do pop up in the work that we do. So you just want to make sure you're aware of them when you see something in this form. You don't get confused and think it's a difference of squares or think that it can't be factored. You at least recognize it, and then if necessary, you can look up the formula to make sure you actually factor it correctly. And if nothing else, like we just did here, you can check your work to make sure it's actually factored correctly, because if it's factored correctly, when you FOIL it out, you'll get what you started with.